Welcome Wildcats. Today we're going to be looking at getting you guys some of your homework help. So this is going to be 4.1 adding and subtracting polynomials. And we're going to go ahead and start. It looked like a lot of people really liked the previous video where I started on the word problems and then went back and picked up the others. So let's see if we can't find the first word problem. Okay, looks like our first word problem is number 12. So we'll start with 12, go through 15, and then swing back to catch number 1. So a rectangle has a length of x. So let's draw ourselves a rectangle. Length of x and a width of 4x cubed plus 8 minus x squared. Find the perimeter of the rectangle when the length is 5 feet. So if my length, x, is 5, this is a strange question because I can just plug the 5 in there. And if I plug the 5 in for each of these, oh, okay, they want the polynomial that models the perimeter of the rectangle. Okay. So the formula for the perimeter of a rectangle is 2 length plus 2 width. So if I take width plus width, length plus length, that should get me what I need. So 4x cubed plus 8 minus x squared. And then we'll have that twice. And then we'll have x and x. So it looks like we have 8x cubed plus 16 minus 2x squared plus 2x. Now don't forget we do need to write this in standard form. So we're going to have our 8x to the third power plus, minus 2x squared plus 2x plus 16. And then since we happen to have this already, it's probably more efficient to just say 8x cubed minus 2x squared plus 2x plus 16, and just plug our 5 into that. So everywhere I see an x, they said since the length is 5 feet, that means x equals 5 because the length was x. So I just took our polynomial that models the perimeter, and I just plugged in a 5 every time there was an x. So that would be 8 times 125 minus 2 times 25 squared is, 5 squared is 25. 2 times 5 is 10 plus 16. 125 times 8 is 1000 minus 50 plus 10 plus 16. So this is 950 plus 26, which is 976 feet. Alright, so the key to this particular problem was remembering that perimeter is 2 length plus 2w. If you remembered that from geometry, you probably were fine on that problem. Oh, this time they're giving us the perimeter and the length and want us to find the width. So for this one, we need to remember that perimeter, which is 8x cubed plus 5x squared minus 12x plus 3, we need to remember that that equals 2 times the length, which is x, plus 2 width, 2w. So I have 8x cubed plus 5x squared minus 12x plus 3 equals 2x plus 2w. And I'm trying to find the width when the length is 25. Okay. So if x is 25, then once again I can just plug a bunch of 25s in here. So 8 times 25 cubed plus 5 times 25 squared minus 12 times 25 plus 3 equals 2 times 25 is 50 plus 2w. Running out of room a little bit at the end here. 25 cubed, 25 times 25. This may take a second, or we can use a calculator. So I'm going to use the calculator on my phone so I don't have to pull up Desmos. So I can do a lot in my head, but large numbers times large numbers is not fun. Because 25 cubed is actually 15,625. It's a big number. And not only is that a big number, but we have to multiply that by 8. So I'm going to go ahead and do that now, which is 125,000 plus 25 squared is 625 times 5, which is 3125. So 25 squared was 625. Multiplying that by 5 gives us 3,125. And then 12 times 25, that gives us 300, but notice that we have this minus sign here, and then this random plus 3 at the end, equals 50 plus 2w. So 125000 plus 3125 minus 300 plus 3 equals 127,828 equals 50 plus 2w. Subtract 50 from both sides, and I get 127,778 equals 2w. And then, now we're down to just 2 times w. We know that the opposite of multiplication is division, so dividing both of those by 2 is 63,889. This just feels wrong. That felt wrong. Especially since, remember, our length was only 25. So this is like a super skinny but super wide rectangle. Very, very strange problem. Cho is making a rectangular garden where the length is x feet. So this is a rectangular garden with a length of x and a width of 5x plus 4. He wants to add garden stones around the perimeter of the garden once he is done. If the garden is 5 feet long, how many feet will Cho need to cover with garden stones? Okay, he's wanting to basically just cover the perimeter. This is just a fancy way of asking what the perimeter is. So once again, we have 2 length plus 2 width, but the length is 5, so 2 times 5, and x is also 5, plus 2 times so this is 5x plus 4, but I've substituted the 5 that they told us x equals. So I've got 5, 5, plus 4. So 2 times 5 is 10, plus 5 and 5, 2 times, 5 times 5 is 25, plus 4 is 29. 2 times 29, so 10 plus. 2 times 29 is 58. 10 plus 58 is 68. So he needs to cover 68 feet with garden stones. Oh wow. From data gathered in the period 2008 to 2012, the yearly value of U.S. exports can be modeled by the function E of x equals that, where x is the number of years after 2008, and E of x is the value of exports in billions of dollars. The yearly value of U.S. imports can be modeled by this function, where x is the number of years after 2008, and I of x is the value of imports in billions of dollars. Are they trying to say that these are the same? Oh, no, 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 no. Okay. So, about blank billion dollars were imported and exported by the US. Remember, and is a word problem version of saying plus. So, estimate the total value of the US imported and exported. So, effectively what we're doing is E of x, which is our imports, plus I of x, which is our imports, and x is years after 2008, which in this case is 2. So we have negative 228 x cubed, so 2 cubed, plus, let's just do the e and the I separately. So we know we're looking for E of x plus I of x, and that's our final answer. But E of x gives us, and x in this case is 2 because they're asking about 2010, which is 2 years after 2008. So we have, this is something that you could just plug in a single string to a calculator. We have negative 228 times 2 cubed plus 225 2.8 times 2 squared minus 6098.5 times 2 plus 11425.8. So if you just plug this into the calculator, any calculator, you'll get your answer. But I'm going to say 2 cubed is 8. And we have 8 times 228, so that gives me negative 1824. 2 times 2 is 4 times 2252.8. So this gives me plus 9011.2, and then 6098.5 times 2 is minus 12197 plus 11425.8. So 1824 negative plus 9011.2 minus 12197 plus 11425.8. That gives me a total export E of x equals 6416. And my imports are what did we say? It's 2 years, so 8 times negative. Let's just do this the way it says. So we have open negative 400.4 times 8 plus 3954.4 times 4 minus 11128.8 times 2 plus 17749.6. And that gives me a total import of 8106.4. So all I did for my import was I took the formula that they gave me, negative 400.4x cubed plus 3954.4x squared minus 11,128.8x plus 17,749.6. I replaced the x's with 2's, and I just plugged that entire string into my phone's calculator. And it gave me 8,106.4. Add that to the 6,416 that we got before, and that gives us a grand total of $14,522.4 billion. They do want it rounded to the nearest whole number, though, so that's $14,522 billion. That's lots of billions of dollars. All right. Those are your word problems. Let's go back to the easy stuff. Let's start at number 1. Enter the polynomial in standard form, then identify the degree and leading coefficient. So, pull this up, move this guy over here. All right, what's my highest exponent? Looks like 9, so I have x to the 9th. Looks like my next highest is 7, so I have minus 24x to the 7th. Next highest appears to be 3, so negative 5x cubed. Then I have an x squared, so plus 8x squared. And looks like next I have a plus 19. So degree of the polynomial is 9, because that's the highest degree, is x to the 9th. Leading coefficient is 1, because there is no number out front, which means we assume it is a 1. It's invisible. All right, add the polynomials. So it looks like on the left I have 68x to the 8th plus 28 x squared minus 8, and then it looks like I have 7x to the 8th, so 7x to the 8th goes there. And then I have 56x squared, but that's negative, so minus 56x squared. Then it looks like I have a 14x, so I really should have left a blank space here. And I'm going to do that now, and I'm just going to push this negative 8 further out. So I have plus 14x plus 4. So 68 plus 7 is 75, x to the 8th. 28 minus 56 is negative 28, x squared, plus 14x, because it didn't have anything to combine with. Then negative 8 plus 4 is negative 4. So just stack them on top of each other. Bring down your answer, and we have 75x to the 8th minus 28x squared plus 14x minus 4. Number 3. Just adding the polynomials again. And let's see, on the right I've got 9, 7, and 2. On the left I've got 9, 7, and 2, so I can just keep those in that order. But let's see, I've got negative 110x to the 12th, and then plus x to the 9th, minus x to the 7th, plus x squared, plus 11x. So that's just me writing them out in order. And then on the right side, I have a negative 9x to the 9th, or sorry, negative x to the 9th. I have an x to the 7th. I have a minus 71 x squared. Okay, so my negative 110 x to the 12th comes down. Plus x to the 9th minus cancels. Minus x to the 7th plus cancels. X squared minus 71x squared is negative 70x squared. And then my x to the 11th comes down, or 11x comes down. So my final polynomial is negative 110 x to the 12th minus 70x squared plus 11x. Negative 110x to the 12th negative 110x to the 12th plus x to the 9th minus x to the 7th. Oh, that's 7x squared, not just x squared. However, 7x minus 21 or 71 becomes 6 higher than that, so that's negative 64. Negative 64. So what I did there was I just, instead of writing 7x squared, I just wrote x squared. Alright, I'm actually going to write the second one on top because it's got more terms, more monomials in it. So I'm going to have 4x to the 5th minus 18x to the 4th minus 10x squared plus 3. And then I'm going to have negative x squared plus 17. So my 4x to the 5th comes down, my negative 18x to the 4th comes down, negative 10 minus 1 is negative 11x squared, 3 plus 17 is 20. So 4x to the 5th minus 18x to the 4th minus 11x squared plus 20. This time we have 3 polynomials, so we'll go ahead and do the same thing where we stack them on top of each other. Looks like I have x to the 3rd, x to the 2nd, x to the 1st, and x to the 0th. So we want to make sure that we get everything in the right column here. So I have x to the 3rd minus 4x squared. And you'll notice on this one I don't have any x's, so I'm going to skip space for my x terms, and I'm going to put my plus 69 at the end. Then I have negative x squared in my second one, plus 3x plus 9. Then in my last one I have 17 x squared minus 3x minus 5. So my x cubed comes straight down because it doesn't have anything else. this is negative 4x squared, negative 5x squared plus 17 is 12x squared. Then I get 0 plus 3 minus 3 is just 0, so those actually all cancel each other out. 9 minus 5 is 4. 69 plus 4 is 73. So I have x cubed plus 12, that's 12x squared. And because all of the x's canceled out, I'm going to leave it out of my answer and just have plus 73. Once again, I have 3, so I need to make sure I get all of the numbers in there, but I have an x to the 4th, an x to the 3rd, x to the 0th, x to the 1st. So right now I don't have any squared, so I can skip that. And I don't have any squareds anywhere in here either, so I can skip the x to the 2nd spot. But I have x to the 4th minus 9x cubed. I can skip x squared minus x plus 8. My second spot I have 7x cubed minus 10. In my third spot I have 2x cubed, this is going to be plus 2x cubed, negative x to the 4th, plus x. So x to the 4th minus x to the 4th, those cancel. Negative 9 plus, well, 7 plus 2 is 9, minus 9, those cancel. Negative x plus x, those cancel. 8 plus 2 is 10, minus 10, that cancels. So, let me see, nothing, plus nothing, plus, well, it looks like nothing, plus nothing is, nothing. Next question. All right. Now we've got a little bit of subtraction here, so they want us to subtract these polynomials. So I see a 5, a 1, and a 0 here. So x to the 5th, x to the 1st, and no x. So I've got 5, 3, 1, and 0. So 24, x to the 5th. I have to skip my x to the 3rd because I don't have any of them on this one. And I have my negative 7x plus 12. And on the bottom, remember, all of my signs are going to change because my second one here. So I have a negative 9, positive 9x cubed, minus x. So that's 24x to the 5th plus 9x cubed minus 8x plus 3. 24x to the 5th plus 9x cubed minus 8x plus 3. Next, once again we have subtraction, so all of these signs are going to change. But I've got 4, 3, no 2's, 1, 0. So 62x to the 4th plus 2x cubed minus 17x plus 4. On the bottom, remember all the signs are going to change because this is subtraction, so I have plus 14x cubed minus 5x minus 20. Alright, so 62x to the 4th plus 16x cubed minus 22x minus 16. 62x, it would help if I actually hit the x, to the fourth plus 16x cubed minus 22x minus 16. Number 9, subtract the polynomials once more. I have an 18, a 3, a 2, a 1, and a 0. So 62x to the 18th. I have a 3, so I'm going to have to skip that one here on the top. So that's plus 0x cubed minus x squared. And then notice that on the bottom I have an x, so plus 0x, and a constant, so plus 0. So on the bottom, everything changes signs because it is subtraction. So I have negative 8x, positive 71x cubed, negative 6x squared, minus 9. So 62x to the 18th plus 71x cubed minus 7x squared minus 8x minus 9. 62x raised to the 18th plus 71x cubed minus 7x squared minus 8x minus 9. And I believe this is our last one. Nope, we have number 11 after this. So number 10, once again, subtracting polynomials. We have negative 11x cubed plus 8x. And then I'm going to put plus 0 because the other side has a constant. On the bottom it is subtraction, so change all the signs. We have negative 6x cubed minus 4x plus 7. So 7, 4x, negative 17x cubed. Negative 17x cubed plus 4x plus 7. Yowza. Okay, so once again we have 3, and the second and third are both subtracted. So I see 5s, 4s, 2s, and 0s. So 3x to the 5th, we have fourths but not on the first one, so plus 0x to the 4th. We have squareds but not on this first one. And we have x to the 0th, which is just negative 6. Okay, so from here on out, all of my signs in this second one change. So instead of having plus 14, I have minus 14. Instead of having plus 12x squared, I have minus 12x squared. And instead of having minus x to the 4th, I have plus x to the 4th. And on this one, I have negative 10x squared. This one all changes as well because of this minus sign, and minus x to the 4th. Yeah. 3x to the 5th comes down. 0 plus 1 minus 1 is just 0. Those all cancel. This is negative 12 minus 10 is negative 22x squared. And then negative 6 minus 14 is negative 20. 3x raised to the 5th minus 22x squared minus 20. That's it, guys. That is all of your 4.1 adding and subtracting polynomials HRW homework assignment done in 35 minutes. Good luck.